Okay, so this is going to be an example of using the equation that I gave you at the end of the last video. So I have two speakers that are placed 3 meters apart, and they're connected to a generator producing sound waves with a wavelength of 0.6. Because I have two sources of sound in the same medium, I'm going to get that two-source interference pattern, where I'll have a second-order central maximum and a first-order maximum, and so on. And if I was to walk from the central maximum out towards the second-order maximum, the sound would be loud at the central maximum, then it would get quieter, and then there would be constructive interference again at the first-order maximum. It would get loud again, then it would get quieter again, and then by the time I get to the second-order maximum, it would be louder again. And in this case, I want to do some math. I want to find the angle between the central max and the second order max. So the equation relating these is m lambda equals d sine theta. We just had to figure out what each of the variables stands for. Well, the wavelength is pretty obvious. It's given up there as 0.6. Okay? And d stands for the distance between the sources. So that was given in the picture as 3 meters. The m is the number of the maximum we're studying. So we want to know the angle from the central maximum to the second order maximum, so m is going to be 2. So we simply plug into the equation. M is 2 for second order maximum. The wavelength was given as 0.6. D is equal to 3. And then sine theta. Now we multiply the 2 times the 0.6, and we get 1.2 is 3 sine theta. Then divide by the 3, and that would give us 0.4 is sine theta. And then do inverse sine and end up with theta is 23.6 degrees. So as long as you know what each of the variables stands for, m is the number of the maximum you're trying to find the angle to, lambda is wavelength, and d is the distance between sources, this should be a fairly easy equation to use.